In this topic, the basic relationship between applied voltage, circuit resistance, and resultant current flow is described. An example is presented to illustrate the concepts covered. Continuing with the discussion begun in the last topic, I'm sure that many of you who have already studied electricity are beginning to discern the development of the basic expression that governs the flow of electricity in all circuits. In this basic circuit, we show the same three characteristics that we have been discussing in the electron circuit. These are voltage, which corresponds to the applied EMF, which forces electrons out of orbit, and is commonly represented by the letter V and measured in volts. Resistance, which is analogous to the binding resistance of the atoms. Resistance is measured in ohms and indicated by the letter R. Electrical current, which is analogous to the electron flow. Electric current is measured in amperes, often referred to as amps, and indicated by the letter I. The relationship between these properties is given by the expression I equals V divided by R. That is, the magnitude of current flowing in the circuit is equal to the applied voltage divided by the resistance. For example, a voltage of 100 volts applied to a circuit of resistance 10 ohms would produce a current flow of 100 divided by 10 equals 10 amps. If we connect a voltmeter across the voltage source, it would indicate 100 volts, and an ammeter in the circuit would indicate 10 amps. From this, we could calculate that the value of resistance is equal to voltage divided by current equals 10 ohms. And yet, in another arrangement of this expression, we find that V equals I times R, allowing us to calculate the voltage when we know the value of current and resistance. The unit of measurement for current flow, that is the ampere, is in practice far more convenient to use than the equivalent number of electrons. Just as a matter of interest, you can note and then forget that 1 ampere of current flow is equivalent to 6.28 times 10 to the power of 18 electrons flowing per second. That is millions and millions, if not billions, of electrons.